Hey hackers, the Coding Kid here. In this video, I'm going to show you how to create a 2D top-down shooter in Godot. This is the finished game. Let's build it. Okay, so first I'll create a new project, and I'm going to call it top-down shooter. And then I'll hit create and edit, and it'll load us into the engine. Okay, now we can add a new 2D scene, and this is going to be the game scene. And let's save this in a new folder called scenes. Okay, and I'll hit save. Now let's drag in a new icon and see if that works. We'll select the current scene, and yes, it worked, although it's not resizing very well. So let's go into the project settings, and in Windows settings we'll change the stretch mode to canvas items. And while we're in these settings, let's also turn on anti-aliasing. I'll set it to 4 times. Okay, let's close that. Okay, now let's delete this icon, and we can also delete it from the file system. Okay, now let's add a new scene for the player. It's going to be a character body 2D, and as a child of it, we'll add a polygon 2D to give it a sprite. But before we do that, let's save it in the scenes folder, and let's also change the background. I'm going to make it a dark blue color. By the way, the background is called the clear color. I'll just make this a bit darker, make it a bit blue. Yeah, that's pretty good. Alright, now let's add the polygon 2D. So polygon 2D, let's make it roughly that big. I'm gonna speed up this part because it's quite boring. Alright, I like that. That's good. Now let's change the color. I'm going to make it blue. Okay, now let's add this to the game. So I'll just drag it in to the center. Now, if we go back to the player scene, Godot is complaining that this node doesn't have a shape. So let's give it one. I'll add a new collision shape 2D node, and we'll create a new capsule shape 2D. Okay, I'll rotate it 90 degrees, and let's drag it to fit the shape of the player. Okay, that's pretty good. Now let's attach a script to the player, and I'll save it in a new folder called scripts, so we can organize everything. Okay, and now let's add a new function to it, physics process. Alright, this function is called by Godot at a fixed rate, 60 times a second by default. What we want to do is look at the mouse position, so get global mouse position. And this is why it's important that our player is facing right. Okay, let's see if that works. Yes, that worked. Okay, cool, but we still can't move our player around. So let's go to the input map in the project settings and add some new actions: up, right, left, and down. And while we're at it, let's also add a shooting action, which we'll use in the future. Okay, up is going to be W, right is going to be D, left is going to be A, down is going to be S, and shoot is going to be space or left click. Okay, let's close that and add some code to make our player move. We'll set the velocity.x to input.getAxes, which will just subtract the negative action from the positive action. So we'll say left and right, and this is going to give us a value from -1 to 1. So we'll multiply it by, let's say, 100, and we'll move and slide and see if that worked. Yes, it did. We can now move left and right. Let's do the same thing for up and down. So we'll set the y velocity to input.getAxes, up and down. Okay, and 100 is a bit too slow. So I'll create a new constant called speed, and I'll set it to 200. And I'll just replace the 100s with speed. Alright, let's see how that goes. Yep, pretty good. Although it's not very smooth, so I'm going to set the velocity I'm going to lerp the velocity using the lerp function. So we'll lerp it from the real velocity, get real velocity, to the velocity, and the weight is going to be 0.1. So it'll move 10% of the way from the real velocity to the actual velocity we want it to be at. Okay, that's pretty smooth. Next, we can add some bullets. So before we add bullets, we need to add a gun. Okay, so I'll add a new Polygon 2D node for this. I'll make it increase in height like this. Okay, this is in the wrong place though. Let's move it behind the player. And I'll change the color to something more interesting. Let's say orange. And I'll just adjust this a bit. Okay, cool. Now let's take a look and see if it worked. Yep, it did work. Very nice. I'm just going to move it a bit to the left so that the center of rotation will be still in the middle. Yeah, better. Alright, cool. Now let's add a new scene for the bullet. It's going to be an area 2D. And I'm going to rename it to bullet. Let's save it in the scenes folder. And before I add the Polygon 2D, I'm going to add a collision shape 2D as a reference. And the shape is going to be a circle shape. And this is for a good size. Okay, and now I'll add the Polygon 2D. I'll make it green, because we haven't used green yet. Okay, let's just follow the outline of the collision shape. Okay, 13 points is good enough. Let's change the player script so that it detects when we press the left mouse button. Okay, so if input dot is action just pressed, and this is going to be shoot, the shooting action, then we can let's just pass for now. But eventually we want to create a bullet. Okay, so if we want to instantiate a bullet, first we need to preload it. So I'll create a new variable called bullet scene, and I'll set it to preload, and then the path to the bullet scene. Now let's create a new variable called bullet, and this variable is going to be bullet scene.instantiate. So this is going to be a new bullet, and the position of the bullet is actually going to be quite hard to determine. So instead of calculating it ourselves, let's just add a new node 2D, and I'm going to position it. Oh, let me just move this a bit more to the center. Yeah, and I'm going to position this node 2D where the bullets are coming from. And I'll rename it to shooty part. Okay, let's get that. So var shooty part is assigned to, and we can use the dollar symbol to get a node. So dollar shooty part. Oh, and it's giving us an error because shooty part needs to be an unready variable. Okay, so we'll set the bullet's global position to shooty part.global position, and then we also need to set the direction of the bullet. But to make the bullet actually move in that direction, we need to give the bullet a script. So let's do that before we set the direction. We'll attach a new script, save it in scripts, and in here we'll create a new vector2, so called direction. So var direction :vector2, and then in the physics process, so func physics process, we're going to move in the direction. So global position plus is assigned to direction times speed, and let's declare that var speed. I'm going to set it to 2. Actually, it's not going to be a variable, it's going to be a constant. Okay, now let's go back to the player script and set the bullet's direction, and this can be calculated if we take the vector to the mouse, which is going to be get global mouse position minus global position, and we need to normalize this, so normalized, so that the x value and the y value go from -1 to 1. Okay, let's see if that works. we'll run it, and oh no, it's not doing anything because I forgot to add the bullet as a child of the game. So we'll get the game. It's going to be $/root/game dot add child, and we'll add the bullet. Okay, let's see if it works. Yep, it's working. It's working very well, although the bullets are going very slowly, and they're also not despawning. So let's first add a timer to the bullet node. So new timer, and it's going to wait for 1 second, and let's auto start it and make it one shot. Okay, and after 1 second it's going to time out, and then in this function we're going to call q3, which will delete the bullet from memory. Okay, let's see if that works. Yep, as soon as 1 second passes, the bullet is deleted. Although the bullet's still going too slowly, so let's set the speed to, I don't know, 10. Okay, much better. Very nice. Now that we have bullets, we can add enemies. But before we do that, let's add a wall so that the player can't just move off the screen like that. So I'll add a new static body 2D, and I'll call it walls. And it's going to have 4 children, which are all going to be collision shape 2Ds. And before we add a shape, let's duplicate them 4 times. So one of them is going to be the top wall, the one below that is going to be left, and right, and we'll make one for the bottom. Okay, and each of them is going to have a world boundary shape 2D. Now this is an interesting node. It's a line that extends infinitely in these 2 directions, but for it to work we need to point it in the direction that the collisions are going to come from. That's top. Now left is going to be another world boundary shape 2D, and this time it's going to point right. Okay, right is going to be again a world boundary shape 2D, but this time its position is going to be different. Let's move it to the right side of the screen, and I'll point it to the opposite of right, which is left. And then for the bottom, again, it's going to be a world boundary shape, but it's going to be at the bottom of the screen. So we'll just change the distance and set it to -648 pixels. Okay, cool, that's done. Let's test it out. So we'll run the game and see if the player collides. Yep, it's working. Let's test the left side, the bottom, that's also working, and the right is working too. Okay, cool. It's time to add some enemies. So I'll create a new scene. It's going to be a character body 2D. I'll rename it to enemy, save it in the scenes folder just like before, and let's add a new polygon 2D so that we can see it. And I'll make the enemies triangles because, well, triangles are, for me anyway, the most hazardous looking shape. Alright, and I'll change it to a nice crimson color. Okay, before we add a script, let's add a collision shape 2D. Let's make it a circle shape, just for convenience. Cool. Now, let's give it a script, and I'll save it in the scripts folder, as always. Now, the enemies are going to move towards the player, so we can declare a physics process. We can set the velocity to the vector in the direction of the player, so it's going to be player dot, oh wait, first we need to get the player, so let's declare that at the start. OnReadyVar player is assigned to root/game/player, and okay, it's going to be the player's global position minus the global position of the enemy, and we'll normalize that to make it always have the same magnitude, and we can multiply that by a constant speed, which will be, let's say, 100, so times speed. Okay, cool. and then we can call move and slide. Okay, and that should work, but we can't test it because we haven't actually created any enemies. So let's create some using a spawning script. So we'll create them periodically every, let's say, 0.5 seconds. And for that, I'll add a new timer node. It's going to wait 0.5 seconds. I'll make it auto start, and it's not going to be one shot because it'll run periodically. And then we'll add a new script. It's going to be the game script, and this is sort of the master script. Let's create that, and then in the timer node we'll click on the node panel and assign the timeout signal to the onTimer timeout function on the game script. And in here we're going to instance a new enemy. And okay, so we'll say var enemy scene is assigned to preload, and then the path to the enemy scene. And then when the timer times out, we'll create a new enemy, and we can set it to enemy scene dot instantiate. And we need to set the enemy's position to a random position that's far away from the player. So first, let's just set the enemy's global position to the player's global position, just temporarily. But to get the player's global position, we must first get the player. So I'll create a new unready variable, unready var player, and it's going to be the player node. Okay, so enemy.global position is assigned to player.global position, and this is just temporary so that we definitely go into this while loop. So while enemy.global position dot distance squared to, and this is going to get the squared distance, which is actually more efficient than getting the normal distance, and it's going to be the distance squared to the player's global position. If it's greater than 10,000 units, it's okay, but if it's not, then we'll set the enemy's global position to a new random position. So enemy.global position.x, we'll set that to a new random integer from 0 to the width of the viewport. So get viewport rect.size.x, and we'll do the same thing for the y coordinate of the enemy's position, and this time it will be the height, which is get viewport rect.size.y. Oh, and actually, this is going to be randi range, randi underscore range, and same thing here, randi range. Okay, let's see if that works. Oh, this didn't work because we haven't named the player. The player is called character body 2D, so I'm going to rename it to player. Okay, let's see if that works. So far, nothing's happening. Let's wait a bit longer. No, 0.5 seconds must have passed. Ah, yes, I forgot to add the enemy as a child of the game. So add child, enemy. Okay, let's see if that works. Oh, and I made a mistake here. This should be normalized. Okay. Yep, it's working. Although the enemies aren't pointing at the player, and we can't actually shoot them. So let's fix those two things. First, let's make the enemy point at the player. So we'll say look at player.global position. Yep, now that's working, but we still can't shoot them, and nothing happens when we collide with them. First, let's make the enemies shootable. So in the bullet script, let's add a new signal, and this signal is body entered. Okay, and let's connect it to the bullet script. Okay, so if the body is an enemy, then we should destroy the enemy and the bullet, but we have no way of seeing whether the body's an enemy or not. So let's go into the node panel when we're selected on the enemy node, and we can click groups here, and let's add a new group called enemies. Okay, and this is going to be a global group, and we can hit OK, and now we can use this handy function in the bullet script called isInGroup. So if body.isInGroup is in group, and this is going to be the enemies group, then if it is in the group, then we can delete the body, so body.queueFree, and we can also delete the bullet. Let's see if that worked. Yep, it did, but we're missing something. there's not much feedback when we destroy these enemies, so let's add some explosions. I'll create a new scene, and it's going to be another node. It's going to be a CPU particles 2D node. Okay, and if we zoom in here, oh wait, first let's save the particles. I'm going to call it explosion.tc. And if we zoom in here, we'll see that there are actually some particles falling here. So let's go back to the inspector and let's increase the amount of particles to, let's say, 50. Okay, now we've got a lot more particles. Let's remove the gravity. So we'll set the Y component to 0. And let's make these particles have velocity. So the minimum velocity is going to be, let's say 122 pixels per second, and we can make the maximum velocity 200 pixels per second, which is pretty fast. Let's actually make it 150, and let's make the minimum 100. In this direction panel here, we can set the spread to 180 degrees, and this will spread them around so they go in all the directions. Okay, but this a bit small, so let's go into scale and let's make this a bit bigger so we can see the full label. Okay, so the minimum is going to be 3 and the maximum is going to be 6. Okay, cool. And let's also add a curve so that the particles become smaller as time goes by. So it's going to be a new curve. The first point on the curve is going to be at 0, 1. And the last point is going to be at 1, 0. Okay, and as you can see, the particles are becoming smaller and smaller, which gives a pretty cool effect. Okay, now let's change the color to the color of the enemies, which is going to be this color. I'm going to copy it and paste it in here. Okay, that's not bad, but these particles are constantly emitting, and the way we can make them not emit constantly is by going up here, and in time, we can set the explosiveness to 1. And this is going to make them all fire at the same time. That's not exactly what I want though, so I'm going to make it 0.86 to make them a bit more spread out. Okay, now the lifetime is too long. I'm going to make it 0.4 seconds, so it's a much shorter animation. And that's pretty good, right? Okay, I'll make it one shot, so it only fires once. And when we create an explosion, we're going to have to set the emitting flag to true. Okay, and we'll create an explosion when we destroy an enemy. So var explosion scene is assigned to preload, and then the path to the explosion. Then in here we can create a new explosion. So var explosion is assigned to explosion scene dot instantiate, and we can set the explosion's position. So explosion dot global position to the position of the bullet. So that's just global position. And then we'll set explosion dot emitting to true. And actually it would be a lot more fun if we make the lifetime random, so some explosions will be bigger than others. So we'll set the explosion dot lifetime to randef range from 0.3 seconds to 0.7 seconds. Oh, and then let's add the explosion as a child of the game. So $root/game.add_child explosion. Yep, it's working. Although the explosions are pretty small. So let's make them a bit bigger. I'll increase the minimum scale to, let's say, 10. And the maximum can be 20. Maybe that's a bit too big. No, that is too big. Let's make the maximum 15 and the minimum 5. Actually, no, let's make the minimum 10 and the maximum 15. Okay, that's nice, although some of the explosions are way too small. So I will increase this to 0.5. Nice. Cool. Let's add some glow to make the game a bit more fun. So I'll go back to the game scene and I'll add a new world environment node. Now it's important that the environment has a canvas background or the glow won't work. Okay, now let's enable glow and just decrease the HDR threshold a bit so that we see some glow, and let's run that. Okay, not bad, although I feel like there could be more glow. So let's decrease the HDR threshold even more. And if there's still not enough glow, we can change the mode. Let's change it to additive glow. And that's a bit too much. I'll make it 0.62 maybe. Still too much. Okay, 0.77 should be okay. Yeah, that's pretty good. And let's also increase the speed of the explosion. I'll just make the max 200. Yeah, that's much better. Okay, now we just need to add one more thing, which is that the game should restart when the enemy hits the player. So in the physics process function, we can loop through each collision. So for iron range, get slide collision count, and then we will we'll create a new variable called collision, and we'll set that to the current slide collision. So get slide collision I. And to see if we have collided with the enemy, we can say if collision.getCollider, which is going to be the thing that we just collided with, dot is in group enemies. Then we can restart the whole game. So we'll say get tree dot get root dot reload. Oh no, it's just get tree dot reload current scene. Now this won't work because it's going to keep trying to reload the scene. So let's add a flag. Var. It's going to be called is reloading. We'll set it to false, and we'll also make it on ready so that it resets after we've reloaded. Okay, so if it's an enemy and we're not reloading, so and not is reloading, then we can set is reloading to true, and we can reload the scene. Okay, let's play that and see if it worked. Yep, it did. Alright, pretty cool. We've finished making the game. That's it for this video. If you liked it, like and subscribe, and see you in the next one. Bye.